Have you ever wondered why a small piece of hardware called GPU costs thousands of dollars and has a market worth trillions? Let's take a deep dive into the world of GPUs, or graphics processing units, and discover what they really are. GPUs were initially designed with one main job: to quickly generate and display complex 3D scenes and objects. Think about the visually stunning landscapes and characters you see in video games, or the intricate models used in computer-aided design software. That's the handiwork of a GPU. But that's not all they do. Modern GPUs also handle tasks such as decompressing video streams, allowing for smooth playback of your favorite shows and movies. Now you might be wondering, isn't that what the computer's brain, the CPU or central processing unit, does? Well, not quite. While a CPU can indeed generate graphical scenes and decompress videos, it's typically slower and less efficient at these tasks compared to a GPU. CPUs are more like the multitaskers of the computer world. They're better suited for general computation tasks like word processing and web browsing. So, how does a GPU differ from a CPU? A typical modern CPU is made up of between 8 and 16 cores. These cores can process complex tasks, but they do so in a sequential manner, one after the other. GPUs, on the other hand, are like a massive team of workers. They have thousands of relatively small cores, all designed to work at the same time. This parallel processing allows them to achieve fast overall processing, making them ideal for tasks requiring a large number of simple operations that can be done simultaneously. In essence, a GPU is like a specialized artist, meticulously crafting complex 3D scenes and objects. The CPU, on the other hand, is like a multitasking generalist, juggling several tasks at once, but not as specialized in any particular one. So, in a nutshell, a GPU is like a specialized artist, while a CPU is like a multitasking generalist. Fascinating, isn't it? But that's just the tip of the iceberg. We've got plenty more to uncover about these powerful pieces of hardware. So stay tuned as we dive deeper into the world of GPUs in our next segment. Now, you might ask, how exactly are these GPUs different from CPUs? That's a great question. Let's dive into the intricacies of these two components and their distinct roles in your computer. To start, consider the central processing unit, or CPU, as the brain of your computer. It's a chip designed to handle a wide range of tasks, from word processing to web browsing. CPUs in their modern form usually contain between 8 and 16 cores. These cores process complex tasks sequentially, one after another, like a diligent worker meticulously completing tasks on a checklist. Now let's shift our focus to the graphics processing unit, or GPU. Unlike the CPU, a GPU boasts thousands of smaller cores. Imagine them as a large team of workers, each handling a simple task but all working together simultaneously. This is known as parallel processing. This difference in core structure and processing style is what sets GPUs apart from CPUs. When you're dealing with tasks that require a large number of simple operations, like rendering a complex 3D scene in a video game or processing a high-definition video stream, you want them to happen at the same time, not one after another. That's where GPUs come in, with their thousands of cores working together in harmony to achieve fast overall processing. But there's more to it. GPUs come in two main types: standalone chips, often found in add-on cards for large desktop computers, and integrated GPUs, which are combined with a CPU in the same chip package. These are typically found in laptops and game consoles. In both cases, the CPU controls what the GPU does, orchestrating the entire operation like a skilled conductor leading an orchestra. So, while CPUs excel at sequential tasks, like a soloist performing a complex piece, GPUs are the champions of parallel processing, like an orchestra playing a symphony. Each has its role, and each excels in its own way. But when combined, they create a harmonious performance that powers your computer. So while CPUs excel at sequential tasks, GPUs are the champions of parallel processing. But why has the AI industry taken such a keen interest in GPUs? It's a question that's been puzzling many, and the answer lies in the unique abilities of these powerful processors. GPUs, or graphics processing units, were initially designed for rendering images, animations, and video. However, their potential extends far beyond creating impressive visuals. In fact, GPUs have become a vital tool in the world of artificial intelligence, where they're repurposed for tasks that go well beyond their original design. How? Well, It's all about the mathematics. Many machine learning techniques at the heart of AI, such as deep neural networks, are heavily reliant on a form of computation known as matrix multiplication. This operation involves multiplying and summing together vast sets of numbers. Imagine you're in a stadium and you need to count all the people in the crowd. If you had to do it alone, you'd count each person one by one, which could take hours. But imagine if you could clone yourself 1,000 times over, and each clone could count a different section of the crowd simultaneously. You'd have your answer in minutes, not hours. That's essentially what GPUs do. They have thousands of smaller cores that work in parallel, simultaneously processing different parts of a task. This ability to perform many operations at once, known as parallel processing, makes GPUs incredibly efficient at tasks like matrix multiplication. In the context of AI, this means that GPUs can process large amounts of data and perform complex calculations much faster than traditional CPUs. This speed is crucial when training AI models, which often involves crunching through enormous data sets and performing billions of calculations. GPUs also have the upper hand when it comes to handling large data sets. They have a high memory bandwidth, meaning they can read and write data much faster than CPUs. This ability to quickly access data is another reason why they're so valuable in AI, where speed and efficiency are everything. So in essence, GPUs have found a new life in the world of AI. Their ability to quickly perform complex calculations and process large amounts of data makes them a vital tool for AI researchers and developers. In the world of AI, speed is everything, and GPUs deliver just that. So what's on the horizon for these mighty GPUs? The future of GPUs is shining bright as their number-crunching prowess continues to escalate. This is largely due to the consistent rise in the number of cores and their operating speeds. As we see more and more cores packed into these chips, we also witness a simultaneous increase in their speed. This combination ensures that the processing power of GPUs is on a steady upward trajectory. Now you might wonder, how is it possible to cram more cores into the same physical space? The answer lies in the relentless advancement of chip manufacturing technology. Companies like TSMC in Taiwan are pioneering this progress. They've been relentlessly shrinking the size of transistors, the fundamental building blocks of any computer chip. As transistors become smaller, more of them can be accommodated within the same physical space. This not only allows for an increase in the number of cores, but also leads to more powerful and efficient chips. The result? More potent GPUs capable of handling increasingly complex tasks. But let's not stop there. The future of GPUs isn't just about packing in more cores or ramping up their speed. There's another narrative unfolding in parallel. While traditional GPUs have proven to be invaluable for AI-related computations, they are not the optimal choice for every task. Remember, GPUs were initially designed for accelerating graphics. Just as they were repurposed for AI, we are now seeing the rise of specialized processors tailored for machine learning tasks. These are often referred to as data center GPUs. Companies like AMD and Nvidia, who made their mark with traditional GPUs, are now evolving their designs to better accommodate machine learning tasks. The result? A new breed of GPUs, finely tuned for the demands of the future. The future of GPUs looks promising, but it's not just about traditional GPUs anymore. Enter the era of data center GPUs, the new kids on the block. While traditional graphics processing units, or GPUs, have proven useful in the sphere of artificial intelligence, they're not the perfect fit for every computational challenge AI presents. Why is that, you ask? Well, it's because the tasks associated with AI are different in nature from those originally intended for GPUs. GPUs were initially designed to render complex 3D scenes and objects, tasks that require a vast number of simple operations conducted simultaneously. This parallel processing ability of GPUs made them an attractive choice for certain AI computations. However, AI computations often demand more than just parallel processing. They also require efficient handling of operations such as matrix multiplication, which involves multiplying and summing up very large sets of numbers. Enter data center GPUs. These are accelerators fine-tuned to expedite machine learning tasks. They've evolved from the traditional GPUs, inheriting their strengths and further enhancing their capabilities to cater to the specific needs of AI computations. Data center GPUs are the result of tech giants like AMD and Nvidia recognizing the growing demand for more specialized hardware in the AI industry. They've tailored the design of these GPUs to better manage machine learning tasks, making them more efficient and powerful than their traditional counterparts when it comes to AI computations. In essence, data center GPUs are a response to the growing complexity and scale of AI applications. They're not just an evolution, but a revolution, offering greater performance and efficiency for large-scale AI operations. Whether it's powering state-of-the-art research or enabling the next generation of smart applications, these data center GPUs are at the heart of it all. So, as we witness the world's growing fascination with artificial intelligence, it becomes clear that GPUs, and particularly data center GPUs, are not just a trend, they're a necessity. They're the powerhouse behind the AI boom, driving innovation and pushing the boundaries of what's possible. As the world continues to embrace AI, GPUs, especially data center GPUs, are set to become even more critical and valuable.